Hello friends, welcome to CS Tuts. Today we are going to learn how we can generate a pushdown automata for a given context-free grammar. We have already discussed about pushdown automata and context-free grammar in our previous videos. To understand pushdown automata and context-free grammars in more detail, please go back to our previous videos. Link for the same is provided in the description section below. Now, today we are going to learn that how can we convert a CFG to a PDA. So, there are 2 points which you must know. The first point is that every CFG can be converted to a equivalent PDA. That means for every context-free grammar, it is possible to generate a push-down automata. The second point says that the constructed PDA will perform a leftmost derivation of all the strings accepted by the CFG. So for all the strings that can be accepted by the language which is generated by the given CFG will be a leftmost derivation in case of the generated PDA. In case you are not clear about the leftmost derivation, you can go back to one of our videos in which we have described about leftmost derivation. Now, before converting a CFG into a PDA, let's describe the CFG and PDA into mathematical form. Mathematically, a CFG can be described using 4 tuples. The first tuple is Vn, that is the finite set of non-terminals. The second tuple Vt is a finite set of terminals. The third tuple capital P is a set of rules which is also known as production rules for the grammar. And the fourth tuple, that is capital S, is a start symbol of a grammar and it belongs to the set of non-terminals Vn. To convert a CFG into a PDA, we must know what a PDA mathematically is. So, a pushdown automata can be represented mathematically using 6 tuples. The first tuple, capital Q, is a non-empty finite set of states. The second tuple, summation, is a non-empty finite set of input symbols. The third tuple, gamma, is a finite set of push-down symbols. Fourth tuple, delta, is a transition function, or you can also call it as a transition relation. Capital S is your initial state, or you can call it a start state, and it belongs to capital Q, that is the set of states. Capital F is a set of final states, and F is a subset, or it can be equal to the set of states, that is capital Q. Now we need to convert a CFG into a PDA. That means we are having these 4 tuples and we need to generate the 6 tuples of a pushdown automata. So there are very easy steps which are followed in order to convert a CFG into pushdown automata. So let's describe those steps. So the first step says that let VT be the input alphabets. So VT is a set of terminals which is given into your grammar. You are going to consider the set of terminals as the input symbols. So any symbol which is present in your VT will be considered as an input alphabet. Now the second step says that let there be only 2 states. First is your start state and second is your final state. That means in your pushdown automata that you are going to generate will consist of only 2 states, start state and a final state. You can represent start state using Q and final state using F. Now it is your choice, whatever symbol you want to use, but there will be only two states in your PDA. Now the third step says that let the stack symbol, that means the symbols of your gamma, be the union of non-terminals and terminals. That means all the terminals and non-terminals present in your grammar will be combined to form the symbols of your stack. If you are done with these three steps, then the fourth step is the major step. According to this step, you are going to define your transitions. That means you are going to define delta. That is your transition function or transition relation. So for the transitions, first step says that add a transition q, epsilon, epsilon tends to f, s. That means for every CFG, this transition is compulsory to be added into your PDA. According to this transition, Q is your start state. The input symbol is epsilon, and on the top of the stack, there is epsilon. That means your stack is null, empty. Then you will move to the state F, that is your final state, and on the top of the stack the symbol will be capital S. That means epsilon will be replaced by capital S. Capital S is the start symbol of your CFG, context free grammar. So you have added this transition. Now let's see the second rule to add a transition. For any production rule which is of the form A tends to alpha, where alpha is a combination of terminals and non-terminals. So you can have a combination of terminals and non-terminals over here. So if there is any such rule in your context-free grammar, then you need to add a transition like this. So according to this transition, F is your final state. F comma epsilon, that means input is null, comma A. A is the symbol in your stack. So A is the symbol in your stack. So you are going to write the left part of this production rule over here. Tends to F, the state remains same. That means you are on the final state itself, comma alpha. Alpha, the right hand side data, you have to copy it over here. Alpha is a combination of terminals and non-terminals, so you need to copy the combination of terminals and non-terminals over here. So you have to add this particular transition in your pushdown automata. Let me repeat it once again so that you are clear with it. For a production rule which is of this particular format where A is a non-terminal and alpha is a combination of terminals plus non-terminals, you are going to write a transition in this particular form. In this transition, F is the final state, so epsilon is the symbol which is your input symbol, and A is at the top of the stack. A means the non-terminal which was present in the left hand side of your production rule. Then you will move from final state to final state. That means there is a loop. You are going to be on the same state. And alpha is a combination of terminals and non-terminals. So the left hand side of your production rule is copied as it is over here. Now, according to the third rule for your transitions, for each and every x belong to Vt, that means for each and every terminal in your context-free grammar, you need to add a production of this particular format. So, according to this production, F is your final state, X is the input symbol. So X is your terminal that belongs to Vt. So for every terminal, you are putting it as an input symbol and also as a top of the stack. Then it tends to F, that is your final state. That means your state is not changing and you are replacing the top of the stack by epsilon. That means you are replacing it by a null. So let us see it once more. According to this rule, for every terminal, you have to add a transition in which you are going to write the final state over here and the terminal which is used in your context-free grammar over here. Suppose you have two terminals, then two productions of this particular format will be there. So you will be writing the terminal over here and then the terminal in the stack will be replaced by a epsilon. So this is all about this particular video. In our next video, we are going to solve an example in which we are going to apply these steps and see how can we convert a context-free grammar into a push-down automata. So thank you for watching our video. For any queries, please leave a comment in the comment section below. Do like and subscribe our channel CS Tunes. Thank you.